name is Edin Arnautovic. I work for TD Tech and serve basically as a technical coordinator for this project. It's a European funded project dealing with hardware abstraction layer for software-defined vehicles. I have to say we are now in the phase of preparing the consortium agreement and NDAs. So this is a generic project presentation. So we will not go too much into technical details. I hope we will have a technical contributions for some of the next Eclipse conferences. So it is a part of this software-defined vehicle of the future initiative of the European Commission. On Monday, the first day, there was a presentation from Ralph about this general initiative. So the European Union wants to support European industry for software-defined vehicles. And this project is one of the set of the projects which will then continue in the next years. So to deal with this topic, with different, let's say, aspects of this general SDV topic. So what is the idea, what is the motivation for this project, also for this initiative? This is from one McKinsey study talking about European perspective and the challenges European automotive industry is facing. So these are challenges also not now new, but let me summarize it a little bit more. So we have this situation and we have from the US big, they call it data-rich giants with Google and Tesla, of course, now Apple, maybe not so much anymore, entering the automotive market with different perspectives, different experiences, and basically threatened also the automotive industry in Europe. And we have also from China, also, let's say, with the government support and also with some kind of regulations pushing electric vehicles and also threatening European market, but also threatening the brands or companies, automotive companies in Europe. And Europe is, let's say, in the middle in this sandwich, facing many challenges. And this study in particular, it is advised that European industry beyond only selling cars, but focus also on different other, let's say, means and also, let's say, some kind of diverse mobility solutions to provide mobility solutions in general, to address the market with some disruptive services, and also, for example, to utilize the car for much longer time. This is a general SDV idea, a general SDV proposal, and here SDV approach would be much of an advance, would fit basically perfectly, and that's why this initiative is also to focus on the European industry and also, of course, the research. So this is a research project, so it's not competitive environment, so pre-competitive environment where universities and companies will work together on these topics. Once more, general idea about software-defined vehicle and the motivation. So we have in the past, and let's say today, the cars are both based on, let's say, maybe some power of the engines, of the characteristics of the engines, the design, and so on. The future would be more that people utilize the car, or even the companies utilize the car much longer, for much longer time, and the new features are not both as once, but you basically can extend the features and even implement the new functions in the software, in the vehicle after many years after SOP. Also here that you have really longer utilization of but also more intensive utilization of the vehicle. So that is also one of the unique points which is changing basically in the industry. So the vision of the project is to create concepts and some kind of modular, flexible concepts which will contain different modules, different building blocks, and which then combining these building blocks would result in, let's say, concrete embedded systems in an embedded system, and these building blocks typically would communicate over service-oriented architecture, but maybe also some other means. And here, the very core idea is, very core proposal is to combine IP-related, also blocks which contain IP, which are closed source, with the building blocks and the modules which are open source, and to create basically, to have really this flexibility to create one complete environment. This vision is also to have even multiple platforms communicating with each other in the vehicle, specific for different domains. So we probably have some modules which are, let's say, generic for security, maybe features and so on for different functional domains, but some of them will be more specific for ADAS or some body or for chassis functions. And on top of these platforms, there's also general SDV idea that you can build applications easier than today, let's say, and also these applications can be done open source or closed source depending on the needs. And here the OEMs should be able to, let's say, combine different modules, different building blocks together and create unique environment, unique system for itself, where this system should have as much as commonality across OEMs, across the industry as possible, but of course not everything will be the same. This is, as I said, European funded project. It's funded partially by the European Commission directly and partially by the local funding agency in the countries. It's coordinated by TDTech, by a colleague of mine, Andreas Eckel, and I'm a technical coordinator. We have some partners for back office, let's say. And here it is a really big project for let's say, European project environment or area. So we have 5 OEMs at the time of writing the proposal. So there was Renault, Ampere, BMW, Mercedes, CARIAD, and Ford. We have also almost all European tier 1s with Valeo, ETAS, Bosch, Conti, Continental, ZF, AVL. We have also even manufacturing, also semiconductor companies inside. We have software technology providers, SMEs. We have many academic institutions, universities, but also research centers, FZI, and so on. And Eclipse is also part of this project, which is very important to support us in open source, especially how to deal with open source for safety relevant building blocks. So Sarah is here involved. We have also affiliated partner, but also associated partner. These are the partners which don't get funding, but also should contribute actively to the project. For example, ARM is here, and also Volvo or some other partners. And also this project is very international, so many countries are involved, 11 countries here, Austria, Germany, France, Portugal, and so on, Spain, many countries, even Turkey is here. The project is for 3 years, so it started this year with some bumpy start, but now we are really pushing really good and I think a very good progress now. And the budget of the project is around 65 millions. So it's actually big project, big endeavor. And the EC contribution is 17, so that's 50% funding more or less, roughly, and 50% of the budget is provided by the industry. So project is organized in different work packages. Just to explain a little bit the organization and the structure of the project. So in the middle you see, let's say, typical V model work packages, V model activities. There's requirements, modeling, architecture, design. The first work package 1, then there is work package 2, which is more detailed design, simulations, and so on. Then you have implementation across different building blocks, integration between different building blocks, between components, but also integration of the use cases on the concrete direct platform. And then, of course, there is a validation and the verification. There is also in the middle here, you see this one work package which is dedicated specifically for safety relevant architecture and safety relevant properties. So we wanted to have this as a separate, let's say, separated environment, separated the work stream to work on specifically safety properties for SDVs. So these are the technical, let's say, work packages, and on top of it, there is a specific activity, work package 1, which should deal with coordination and alignment with all the other associations, projects in these environments. For example, Eclipse SDV, SOFI, COVESA, also other European funded projects in this environment. So that is really important now, not to, of course, reinvent the wheel, but to build on the works before, and also to provide foundations, since this is about hardware abstraction layer, to provide foundations also for the future project and also research projects, but also for the industrial projects. There is another work package dealing with general mindset building and dissemination and exploitation planning for after the project. This is a little bit more about the organization, the structure. So work packages in this project deal with how to work together, how to coordinate, provide, let's say, processes, structure, templates for the working together. This is how to really organize these 50 partners with many, even more than 100 and many hundreds maybe people involved. These are the work packages. These are the horizontal activities, and then we have transversal activities, which basically these deal with the content, with specific different content on the project. So there are 3 kinds of these activities. We have building blocks activities. These are 6 of them, and they are responsible. They are kind of mini projects inside, responsible for different specific topics of this hardware abstraction layer. Then we have enabler activities which support these building blocks, technical activities in the terms of how to update, what would be the generic way to update software, maintenance, and so on. And then we have also 2 transversal activities for mindset building, communication, dealing with, for example, nomenclature definition, and so on. And at the end, last one is the use cases. So you see, for many of these activities, so sub-projects, so to speak, we pass through the whole V cycle during these 3 years. Of course, this is a research project. We don't really start with, let's say, very concrete technical requirements as you would start for a serious product or serious project, but there are some high-level requirements, and then during the projects they are implemented, evaluated, and also maybe even changed and so on. So this is, as I said, pre-competitive environment, a research environment, and not really commercial collaboration. So here are more details about these transversal activities, about the topics inside. So we have 6 of them. First is hardware software abstraction. That is maybe the biggest one and the core activity in the project. And these activities should result in some building blocks, or really some tangible software which will be tested, evaluated, and so on, and potentially be a basic for future products and future projects. And there are different topics which are addressed. And some of the topics are, let's say, rather concrete. They really represent a building block, software building block, and some of them are generic and can affect many software parts. So we have, for example, hypervisor, middleware parts which are related to hardware abstraction layer. We have the fragmentation of the interfaces as an important topic here, interface concept, data architecture, also here container isolation, and so on. So then we have the B. This activity deals with general APIs and interfaces. So, for example, VSS is the topic. So the partners working in this project will then work together with Covesa and work together on VSS specification, general about integration of the aspects of the integration of the SDVs, plug and charge aspects, and so on. Then we have a mixed criticality integration platform. This is also a rather concrete part where we have a software environment for that. Then we have, for example, dealing with mixed criticality, mixed with scheduling, with scheduling for network and for the software, and shared memory access. So this is all the topics which will be addressed in this activity. We have the D. This is a cybersecurity orchestration. Also here some generic part, for example, security threat analysis, how to deal with security threat analysis in the SDV environment. Do we need the new concepts here, new methods maybe, new tools? So some partners will work on that. Also working on security analysis for specific building blocks in the platform. Security gateway service is also one topic. Then there is the E. It's about the tools. You have here tools and processes, so Linux here for safety Linux, tools for architecture modeling for SDVs, and the last one is integration testing and simulation. So here virtualization is also a part, replay simulation, reprocessing, and so on. These are the technical activities. So in each of these activities, there are multiple partners working together or alone, but most of them hopefully work together on these topics. And then we have enabler activities which support the technical ones. For example, as I said, in terms of maintenance, isolation of applications, or cybersecurity regulations. And then there is this efficient activities with mindset, for example, what is now automotive grade, to define and show and to support the technical developments in the project. So here you see also maybe very known picture about this layered architecture with the hardware, abstraction, operating system, middlewares, and applications, and so on. And this is a little bit mapping, let's say initial mapping of these defined topics. What we will do on these layers, most of them should be in the hardware virtualization and let's say these lower levels, but some of them also affect other layers. Also here, distinction between onboard and offboard. So here, offboard is not really the topic here, but we have a tools and software development kit, which is also here important. These are the objectives of the project as defined in this big proposal document for European Commission. So that is, we have several of them. So the platform architecture, so that is basically the overall objective to achieve the platform architecture. General SDV, let's say, idea to keep the hardware the same, to have a new card, let's say, just software updates and functions. And also, as I said here, to work together with Covesa, Sophie, and all these activities and build on top of that and use this funding from the European Commission really to not only, let's say, to talk, but really to provide some prototypes and building blocks as a result. Of course, architecture is very complex and sometimes a little bit diffuse topic. So now what we want to do is start with some concrete use cases, some real examples, and then basically play them through and see what building blocks are needed and what interfaces, and start to work from the architecture from this point of view. Also, we worked with Martin from Continental with that and so on. So yeah, also contact to Sophie will be created. Then the next objective is abstraction from hardware, virtualization, memory management, and so on. So here's to define the interfaces, even here, for example, to exchange sensors, actuators that can be easily exchanged, that we have defined APIs to work on that. And also the vision to even exchange software to, let's say, even reallocate software parts from one computing node to the other and see what kind of interface, what kind of abstractions are needed there. I mean, of course, there are some different approaches already, but here to really see what is missing there and how we can achieve this. On the hardware side, the idea is to support different hardware computing environments, safety controllers, GPUs, microprocessors, also going to RISC-V, to see what is needed there for hardware abstraction. Beyond that, integration is, of course, should not be neglected. We have to support integration, easy integration with different operating systems, and provide tools and support for easy integration. For example, there is one big topic dealing with this integration platform, and so on. Yeah. One more objectives. So, of course, safety features. So they are often maybe basically critical, very difficult to deal with that, especially, for example, to ensure freedom from interference on such centralized computing. If we use that freedom from interference in the space, let's say, in the memory and cores and so on, but also in the time domain. So that is also an objective. Security is objective as well, and how to use the edge here. Also, the cloud is not so much in the focus, but maybe also to not forget about this, how to, for example, move some loads, some computing loads to the edge, and at least provide here the basis for that, and the tools at the end, how to configure everything is also an objective. So the expected impact of the project, and also after the project, even more important. One of the most important impact is really beyond, of course, creating these building blocks and prototypes and the basis for the hardware abstraction layer, but really to create this European ecosystem and to reduce basically the let's say the overload in getting new products and so on. So to reduce friction, basically, like by creating this European ecosystem. This ecosystem is here shown there. So we have OEMs, we have technical suppliers, we have tier ones in the project, but also working together as let's say associate members. We have on the right side. Infineon is, so, for example, these silicon vendors. We have different associations here, also different other projects. For example, Federate, SOFI, and so on. And on top of there is a European Commission, which funds different programs. So this is a ChipJU project, but there are also some other programs, CSECAM or 2.0, which fund a little bit different areas. Let's say they go more into application side of the things, autonomous driving, or 2.0 more about these electrical vehicles. So yeah. This is basically the last slide. So just about planned cooperation again with the different organizations. With Federate, Federate was also mentioned here. This is a, let's say, kind of umbrella European project, not really doing development, but doing coordination of these different aspects, different projects with other organizations, but also within European ecosystem of European funded projects. Then we have Covesa working with them, VSS, SOFI, SoftICAR is a big German project. ELISA, Safe Linux is also would be a topic to address or to work together, and drive. So this is basically it. As I said, we are now in the process of we already started working, but we still don't have all the agreements. So this is basically the approved presentation from the consortium, and I hope next time there will be more technical contributions to the open source and also community and also to the Eclipse conference. So any questions, I'm open to it. Thanks a lot. Yeah.
Thank you. Thank you. In typical fashion, I'm going to steal the microphone initially. I'm really curious. So HAL4SDV is an initiative that's funded by the European Union, and some of the members are also funding it? Some of the other people in that circle are co-funding it, or is it primarily funded by the European Union?
It is funded, so let's say 25% roughly comes from the Commission, the European Commission, 25% from the local funding authorities, and the rest is the industry itself.
Okay.
So let's say we get 50% funding for the budget that we have.
So the initiative is going to be looking at identifying those different building blocks to put together this HAL4SDV?
Yes.
So if, I noticed Covesa and SOFI was mentioned quite a few times, but there's a lot of software being developed through Eclipse. Is this an opportunity for projects that work in Eclipse to potentially reach out to this initiative to obtain some funding to help with the project growth? Or how does, like this?
No, people, let's say partners participating in this particular project can of course contribute to Eclipse projects or even create a new project. That's definitely possible. But partners then can maybe contact and then create a potential new projects, but not for this one. So this is already kind of finished. There are a limited number of partners which are defined. There is a contract and so on. But of course, for future projects, anyone can contact and we can create a new projects and new proposals.
At the end of the day, it's to build a software stack, right? A software and hardware stack?
Yes.
Okay. So if that's the case, then you don't have that already. You're assembling it, working with all these partners.
Yes, yes. For example, Continental is anyway working in the Covesa or whatever, so that a part of this will probably then be in this project and so on. So it should not be some kind of separate activity from all the others. But with the funding, of course, there's a reduced risk and also motivation for companies to really then work on this topic even with more commitment.
So, because in my position when I used to work at GM, I was witness to probably 7 or 8 different full stack SDV software solutions. And so is the idea with this initiative to come up with one reference open standard one, or just to help those 7 go to market, or like what is the end?
Maybe it would be, I don't know, too idealistic that we said now we create a complete one, but at least the building blocks which can be used by OEMs to combine their own system. These building blocks hopefully will work together better than if we have some kind of structured and defined environment where we work together. So there is not an idea really to start from scratch and develop everything kind of new stack, but work as anyway people are motivated to work on a stack.
Okay, so rather than developing them from the scratch, this initiative is considering looking at the ones that are available. Because I saw you mentioned.
Yeah, of course, yeah.
Okay.
Yeah.
Okay.
And this is basically top down. So on the top there is in the project structure to really deal with that. There is a work package which really should focus on integrating everything what is existing there and also collaborating with the organizations. But also every partner participating there should be aware that should not start something new which something is already there, but really for itself figure it out. Yeah.
So Eclipse projects that exist that would like to find out more or get more involved, they should reach out to the Eclipse Foundation, who is a part of this initiative.
Yeah.
Okay.
So Eclipse is anyway part of the project, so as a member. So yeah. And, yeah.
Okay, thank you. Any other questions? Alrighty.
Thank you for the presentation. First, my question maybe is not that simple one. I try. I'm working on projects for years, mainly from the cloud backend perspective, but mainly on connected services. Okay, so I know also the car, the infotainment part, very well, and the experience regarding the cloud. The closer the SOP comes, so we have two types of integration. Okay, so one integration we're having in the car, and the second integration come after the SOP, where you integrate the car with the backend or finalize the integration. So would you say, according to your plans and building blocks, would you say out of your mind what I'm talking about? Would it be for you typical integration, or do you think there's maybe also another part of integration where the backend becomes integrated? I mean, it will become, I think, more and more essential as almost the full car. You know, the whole car is becoming connected, right?
Yeah. Well, I mean, this particular project, as I said, it's dealing mostly, so it does not really deal too much with the let's say this off-board part with the cloud. So it's really dealing mostly with the embedded part. So that is now one project. There will be another project. It's now in the evaluation phase, dealing more with middleware, and this extends more towards the cloud then, and of course then considering integration of the functions from the cloud as well. And then next one will be also coming with tools and so on. So this one is more focused, let's say, on the embedded part, not so much on the cloud part.
So there are two separated building blocks or projects?
Yeah.
Like
So would be, we have a project now, a proposal pending, which was submitted to commission, which we will get answer probably in 1 month, and then the next project will start in, let's say, 6 months, which deals with middleware, for example. Yeah.
And are you open for exchanging experiences? Regarding that, because I mean, there are plenty of services where it not ends in the car, but going to the backend, right? And the customer or maybe also the project lead expects a running function, right? And so.
Yes. Yeah, I mean, of course, we are open for exchange. And in particular, this may be best addressed to the specific partner working on this area. We have 50 partners, so that's really a kind of complex organizational structure. So we have to figure out, we can also together figure out which partner would be interested there. But from which company are you?
Baltic Mobility.
Okay.
So we are part of Carriot, so we are collaborating with Carriot, yeah.
Okay, yeah. But Carriot actually started as a partner now. Let's see what happens. Yeah. But let's see what happens.
All right, next.
Maybe just to add to the previous question, so the hardware abstraction layer is below the operating system, so it's not targeting to be like on this cloud-connected layer, let's say. So that's maybe the thing.
Yes.
I did see in one of the first slides it talked about a communication middleware and a few other things that
there is touching. There are some building blocks activities which will touch a little bit also the middleware.
It is vehicle focused, but you did mention you don't want to forget about the cloud and connection to the cloud. So
Yeah. So it is as in terms of disparity, execution, and so on. So it should also address a little bit the cloud. But as I said, we are now in the phase of defining requirements, high level, what people really do, and the project will last for 3 more years. So, yeah, it's also a research project, so it's many things are still, let's say, a little bit fuzzy what the result will be.
Okay. Any other questions?
The second question would be maybe about potential collaboration model or even development models. So many people were talking those days about automotive DevOps or DevOps in general. So is it also something where you focus on? Sorry for that, but fool with a tool, is still. So and we know that there are validation, verification. It's a very cost-intensive thing, and SDV having also the promise, of lowering the cost and all that stuff. So do you plan also having a kind, I don't know, of blueprint in how we can, have that whole thing of fail fast, fail often, that stuff, from digital?
Yeah, it is some of the topics address this. For example, there are complete activity dealing with process tools, for example, for modeling side, but also here integration testing and simulation. So there are some companies and universities who work on different here tools, interoperability, and also I think it's inside inherently, yeah. But there is now not a complete solution or complete vision how this will look like.
Okay, thank you.
Not yet, yeah.
Last call? No? Okay, thank you very much. Thank you.